Okay, so this is the final day of 30 days of understanding the modern AI stack series, mini series. And we spent the last 29 days understanding every moving piece of the modern AI stack, from tiny gradient inside a neuron to full agent loops and scaling patterns. So now it's time to put everything together. And instead of just building another demo, we are building something real, something I actually want to use every day, something big companies don't want us to have. So hi, I'm Krishna and we are building ARIA, adaptive reasoning and intelligence architecture. Think of it as my version of a personal AI OS, voice native, tool powered, memory driven, and fully local, and much more. ARIA is basically going to be your second brain. You talk, it listens, it routes your query through the right pipeline, searches your documents. It called tools. It is going to remember things about you. At least this is what I'm planning to do. And we'll see what happens with this project. And it is going to talk back instantly. At least I'll try to do it. And nothing is going to leave your computer. No cloud lock-in. No sending your whole life to big AI companies. And your data stays with you. Okay, so we'll try. Okay, so here's the plan. We are building this end to end right in front of you. Like I'll be using LLMs as our co-engineer aggressively. And I'll create files, generate boilerplate using my AI. I'll explain the logic and gradually assemble the whole system. I can't promise you a polished final product in just one video. I'm just going to show you what am I able to accomplish in just one setting. So you'll see like how someone actually builds an AI, a full AI system with modern tools, the messy, real, fast way. Okay, so yeah, let's start. So the first thing first, I'm going to structure the setup of all these files. I'll create all the files that we need and the directories we need. So now that the project skeleton is ready, folders, when basic dependencies. So let me walk you through the core files we already have, like how they actually work together. This will make the rest of the build super easy to follow. So the first one is we have is config.yaml. Initially, I was wondering myself, like, why do we need this? So basically, this is the brain of the entire system. All models, chunk sizes, rack settings, memory limits, and file paths, they live here. Every component, router, RAG memory, tools, all read from this one file. So let's say if tomorrow or any other day, I want to switch the router model from Groq. Actually, here we have Llama, which we are using from the Groq. So we want to switch it from Groq or Llama to whatever we want to. So I won't be touching like 15 other Python files. I just change one line here. It's basically ARIA's settings panel. Next we have is a .env file. I can't show you because we store private keys here. So this file is simple but important. Or your API keys, Groq, your Heavily, whatever, you go here. Nothing is ever hard coded inside Python. This keeps the project safe and clean. Let us now go to the code directory and chase.py file. So it's a observability backbone. So one of the coolest part is that every stage of the pipeline, like routing, retrieval, re-ranking, LLM generation, tool calling, calls trace.stage. Here it is, like trace.stage. Okay, so ARIA logs stage name, latency, token usage, and errors. And when our full query is done, it writes everything to our .jsnl trace file. Here it is, like .jsnl file, and we write it back. And this is what makes your AI system inspectable. You can literally see how ARIA's things step by step. Now let us check out router.py. So this file is the most important one in the whole system. Like every incoming queries goes through the router first. No exceptions. The router decides which path the query should take, like the conversation, RAG lookup, tool call, or deep research, or memory write. It uses Groq because routing has to be fast. And we enforce strict response format, so it always returns clean JSON. And this is exactly how we avoid the hallucinated tool problem that drove my agent last week. We were trying to build. Now let's check out this tool registry. And here we have our all tools register mapped tool register dot mapped. So this file defines what tools ARIA has access. Like two things live here: tool descriptions. The LM sees these, and the Python function mappings, the code that actually runs. If I want to add a new tool like get weather or control Spotify, I add one entry here. Like I can add tool here and entry here, and the rest of the system works automatically. No other file change. Now let us check out this tools directory. So the first thing, let us go to web search. So Tably wrapper. So we are using this Tably wrapper. So you can check it out. Like what's Tably. So just one function is structured output, no jump. Like you can check it out. One function and nothing else. Like description log. This is a tool definition. Okay. So yeah, this we are using Tably. It gives us about 1,000 credits for free. That's why I'm using it for searching. Like if you want to search something online, no? Now we check out this calculator wala thing. It's easy. So it's like it uses Python's AST parser, not eval. So you get to save arithmetic without opening security holes. Okay, so now let's go to memory tools. So this reads and writes into memory.json. Everything you want ARIA to remember long term, like your preferences, facts about your workflow, personal details. This file handles it. Now you can go to orchestrator.py. So this is the agent loop. It sends your query to the LLM. Like check if the model wants to call a tool, execute that tool, feeds the result back, and loops again up to 5 iterations. Like here it is. Like it will loop for about 5 iteration. And when the model stops calling tools, it outputs the final answer. And this is basically ARIA's reasoning engine. And now that all the core pieces are in place, I'll do the other things and we'll show you. Like we need a RAG module and the core pipeline wala thing. So let's move to the next part. I'll show you there. All right. Now let's walk through the last set of files we built today, because these are the ones that actually glue the entire system together. So core pipeline.py. This file is the actual orchestration engine. It takes your raw query and decides how to route it. If the router says it's memory write, we fetch memory tools. And if it's a RAG lookup, we run the retriever. If it's need deep research, we trigger the agent loop. Otherwise, straight conversation response. Pipeline itself never calls the LLM directly. Its only job is to coordinate who does that, in what order, log everything in the trace file. And this is basically the operating system of ARIA. Now let us go through the RAG module. Now let me show you embedder.py. Just turns the text into vectors and saves into vector.db. This one loads our embedding model or MIDI-RM L6v2 and converts text chunks into embeddings. It's simple on purpose, single responsibility, nothing else. And model loads into memory, so RAG stays fast, like global wala thing. So if we show you vector store.py, this wraps the chroma DB, so we don't work with the raw chroma calls everywhere. We have add documents to store embeddings, query to find relevant chunks. So everything is saved locally into uh, data chroma DB, like where it is. You can see in a config.py, like yeah, data chroma DB. So we don't need any network, no privacy issues. It's all saved locally. Now let us see retriever. Let us take a look at retriever.py. So this takes a natural language query and runs a semantic search through the vector store, filters chunk, and returns clean labeled context. It also logs every retrieved chunk into the trace so we can inspect RAG decisions later. This file make your RAG accurate instead of chaotic. Though I still need to write the ingestion.py to be able to read PDFs and markdown and anything we want to save, like our personal documents now. That's from where we will be able to search, like get personal context. So like chunk them, embed them. So these are all things that we need, like embedder, retriever, vector store. But before that, we also need ingestion to ingest those documents and save them and chunk them and embed them. So I'll finish this, and when I finish the final build, okay, so now let me show you recall.py, memory recall.py. So this loads everything ARIA remembers about you from the memory.json. Formats isn't memory first, old memories later, and gives pipeline a clean block of human readable memory to inject into prompt. There's nothing saved yet, so it just returns an empty string. Now comes our main.py. So this is the entry point. So this is the entry point. It boots the whole system and prints a clean minimal UI using rich, and then starts a loop. I found about rich while I was talking to LM. Like there is something like rich, which we can use to like print clean minimal UI. And so yeah, so we just like we just takes our so we just take our query and pass it to pipeline, and print response, show live timings for each stage. And this is the command line version of ARIA until I add the full UI. All right, let me run this thing. And yeah, now it's running. You can send any message. Let me just say hi. It says hello. Let me show you what we are using for this LLM generation wala thing. We're using a Moonshot AI Kimi K2 instruct. It's too good. Like it's better than Llama. I was getting some problems with Llama. Like wasn't like it was causing some problems with tool calling. Now let me show you. Like let me ask it. How's the weather in Bihar? Let's be specific. Let's say Ghaziabad. You see, it called memory record to find if something is there, and then it is using our tool web search and then LLM generation from the context we get from the web search. Now, like you're getting this, hey Krish, like when I tested it, I told it to save my name. So I said to like save my name as Krish. So it's using that too. So you can see like it fetched the weather of Ghaziabad. Now let me say to change my name. Let me say to change my name. Change my name to Arya, not Arya. Arnav. So let us change my name. Or, now let us ask something else. Okay. So we can ask, should we ask tools do we have? Like, let's just say what is plus, first using the router model, the LM, figure out like what we need. We need the generation or tool or something else first. So use tool and calculate it, the sum. We use LLM generation to generate the output. Now let me ask something based on the tools we have. Let's say we don't have much tools right now, but we'll add more to it. Uh, let's say, let's say, save my girlfriend name as Arya. So yeah, let's save like who's my girlfriend, like Arya. So I'll say write a poem about my girlfriend. Let's see if it catches that name from the memory.json about my girlfriend and me. Okay. So yeah, so it goes to LLM. It directly goes to LLM generation. But yeah, but it remembers like we, because it is in the current session. Like yeah, after a few off, it will use the, so yeah, it is using the name, but it's not printing like, I don't know why. I checked it out. So yeah, between us, Arya, a quiet thread. Okay, it's pretty good. To save my date of birth. Let me tell it to save my date of birth. Save my DOB, not date of birth. If it catches that, what I meant to say, as 18. So it goes to memory recall. So it has saved that date. What we can do. I guess that's enough for today for this video. So yeah, so we'll eventually build automatic retries and fallback models for the problems I told you. Like I was getting some problems with the Llama, because Llama is not good with tool calling. But yeah, it's working with Moonshot AI wala thing. So you can see like it's pretty good. Like that's honestly what I managed to pull off in one sitting, and it's pretty wild. Like it's going back to memory recall and then generating LM generation wala thing. The project we did the last week, it was pretty bad. Like it wasn't as good as this one because of maybe the way we structured the LM queries and all. But now it's working with this, and we have a long way to go to build this project. The vision I have in my mind for now, ARIA responds to queries, remember facts, and run tools and logs everything. So I'll keep improving this and add ingestion UI connectors memory, connectors to connect maybe your Spotify playlist or more things we can connect, like X, the social media account we can connect. And when the full project is stable, I'll push it to GitHub. Maybe I should push it now, like whatever I have. So you can go to the description, check out the link. I'll push it right now. So yeah, now it's late. I need sleep. So, but Arya is officially alive in my laptop. So yeah, so that's day 30, the end of our 30-day series, 30-day mini series. And we'll continue this 365 wala thing. We'll continue this 365 wala thing. Like this is day 62 of 365 days of making videos. It's pretty wild. Like I can't imagine how long I have pushed, like 62 days. These videos are not short, like 30 second, 50 second. These are over a minute video. And yeah, we'll see like what we do. The next one, maybe we'll yap for a few days and we'll see. So yeah, Let's do it.